Hello students, welcome to JSM. In previous videos, I have explained introduction of hybridization and how formation of hybrid orbitals are taking place. How formation of hybrid orbitals are taking place. In this video, I am going to explain how sp2 hybrid orbitals are forming and how sp2 hybridization is taking place in organic and inorganic molecules. So first, sp2 hybridization, sp2 hybridization, sp2 hybridization. Okay, we know that hybridization. What is hybridization? The process of intermixing of atomic orbitals having slight or same energy difference and different shapes to give or to produce same number of identical new orbitals, known as what? Hybridization. Here sp2 hybridization means what? One s orbital and two p orbitals, combines to give 3 sp2 hybrid orbitals, known as sp2 hybridization. So now these are the sp2 hybrid orbitals are first hybrid orbital, second hybrid orbital, third hybrid orbital. Okay, so now these are hybrid orbitals. So now what is the shape of sp hybrid orbitals? Trigonal planar. So trigonal planar. Okay, what is the bond angle? So bond angle is 120 degrees. So now this is the formation of sp2 hybrid orbitals. Okay, how many are involving? One s orbital and two p orbitals. It gives what? 3 sp2 hybrid orbitals. Okay, these hybrid orbitals geometry is what? Trigonal planar, and bond angle is how much? So bond angle is 120 degrees. So let us take an example of sp2 hybridization. So first inorganic example I am taking. What is that? Boron trifluoride. In this boron trifluoride, central element is what? Boron. Atomic number 5. Electronic configuration 1s2, 2s2, 2p1. 1s2, 2s2, 2p1. Outermost electronic configuration 2s2, 2p1. 2s2, 2p1. This is 2s2, 2p1. Okay, this is also known as ground state electronic configuration 2s2, 2p1. This is 2s2, 2p1. Whenever we give energy to this orbital, this is the electron excited into p orbital. Same, this is the process is known as excitation. So now in excited state, the electronic configuration of boron is 2s orbital having 1 electron and 2p orbitals are having 2 electron. This is known as first excited state electronic configuration. What is the hybridization? sp2 hybridization. So now this is s orbital, these are p orbital. One s orbital, two p orbitals combines to give total 3 sp2 hybrid orbitals. Now 3 sp2 hybrid orbitals. Where at boron we have 3 sp2 hybrid orbitals. Now I am writing hybrid orbitals at boron. So now boron, first hybrid orbital I am writing. So here it is first hybrid orbital, second hybrid orbital, and third hybrid orbital, each orbital having one unpaired electron. Unpaired electron. So now this is the hybrid orbital spot at boron. Now second element is what? Fluorine. So now I am writing fluorine. Fluorine atomic number 9, electronic configuration 1s2, 2s2, 2p5. This is the outermost electronic configuration 2s2, 2p5, 1, 2, 3, 4, 5. This is px, py, pz. Okay, pz orbital having one unpaired electron. How many fluorines are there? 3 fluorines. So now how many pz orbitals we will get? 3 pz orbitals. 3 pz orbitals. So now 3 pz orbitals of fluorine linearly overlaps with, which overlapping? Linearly overlaps with hybrid orbitals of boron. Hybrid orbitals of boron. So now first pz orbital, second pz orbital and third pz orbital. So now first electron, second electron, third electrons of what? Pz orbital of fluorines. So now which overlapping? Linear overlapping. So formation of sigma bond takes place. Formation of sigma bond takes place. So now here boron 1, 2, 3. So now what is the geometry? Trigonal planar. Trigonal planar. Fluorine, 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 and the bond angle is 120 degrees. Bond angle is 120 degrees. How many sigma bonds? So now total 3 sigma bonds are there. There is no formation of pi bonds. Next example is organic, that is ethylene molecule. Ethylene molecule. Formula of ethylene molecule is C2H4. C2H4. This is ethylene molecule. Ethylene molecule. So now in this ethylene molecule, central atom is carbon. Atomic number 6. Electronic configuration 1s2, 2s2, 2p2. 2s2, 2p2. It is 2s2, 2p2. This is outermost electronic configuration. So now 2s2, 2p2. 2p2. This is also known as what? Ground state electronic configuration. Ground state electronic configuration 2s2, 2p2. So now whenever we give energy to this orbital, this is the electron excited into p orbital, process is known as what? Excitation. Process is known as what? Excitation. So now in excited state electronic configuration of carbon 1, 2, 3, this is known as what? First excited state electronic configuration. First excited state electronic configuration. So now s orbital, these are p orbital. So now what is the hybridization? Hybridization is sp2 hybridization. One s orbital, 2 p orbitals. One s orbital, 2 p orbitals. So hybridization, how many total? 3 sp2 hybrid orbitals. 3 sp2 hybrid orbitals. Okay, so 3 sp2 hybrid orbitals are formed. So now another one more orbital is there which is not involving in hybridization. Not involving in hybridization, but it is having one unpaired electron. This is known as unhybridized orbital. Unhybridized orbital, or this is also known as atomic orbital. This is also known as atomic orbital. So now here at carbon we have 3 sp2 hybrid orbitals. How many carbons are there? 2 carbons are there. So total for 2 carbon atoms we are getting 6 hybrid orbitals. 6 hybrid orbitals. So now I am writing 6 hybrid orbitals of 2 carbon atoms. Okay. So first hybrid orbital, second hybrid orbital, and third hybrid orbital of first carbon. So now first hybrid orbital of second carbon atom, second hybrid orbital of second carbon atom, third hybrid orbital of second carbon atom. So each orbital having one unpaired electron. So first carbon atom having 3 unpaired electrons, and second carbon atom also having 3 unpaired electrons. Okay, so now here which overlapping? This is the linear overlapping. Which overlapping? Linear overlapping. So formation of which bond? Formation of sigma bond takes place. Okay, so now here, so this is the hybrid orbitals part. Hybrid orbitals part. So now second element is what? Second element is hydrogen. We know that electronic configuration, atomic number 1, electronic configuration 1s1. 1s1. How many hydrogens are there? 4 hydrogen. So that we are getting 4 1s1 orbitals of hydrogen. 4 1s1 orbitals of hydrogen. So now 4 1s1 orbitals of hydrogen linearly overlaps with hybrid orbitals of carbons. Which overlapping? Linear overlapping. 4 1s1 orbitals of hydrogen linearly overlaps with hybrid orbitals of carbon. So that formation of 4 sigma bonds takes place. Okay, 4 hydrogens. First hydrogen, second hydrogen, third hydrogen, and fourth hydrogen. Which one? Sigma bond, sigma bond, sigma bond, sigma bond. Okay, hybrid orbitals part completed, and second element hydrogen part also completed. So now we have what? Unhybridized orbitals. How many? 2 for one carbon, 1. Here we have 2 carbons. So now 2 2 unhybridized orbitals. 2 unhybridized orbitals. These orbitals also having one unpaired electron. So here which overlapping is possible? So there is no chance to linear overlapping. Here is a chance to what? Lateral overlapping. Okay, so now here it is what? There is no chance of formation of what? Linear overlapping. There is no linear overlapping. Which overlapping is possible? That is parallel or lateral overlapping. So now here lateral overlapping. So due to parallel or lateral overlapping, formation of which bond? Pi bond takes place. Formation of pi bond. So now between 2 carbon atoms. Between 2 carbon atoms. Now here it is what? Here it is a sigma bond. And here it is what? One pi bond. One pi bond. Between carbon and hydrogen, one sigma bond. Between carbon and hydrogen, one sigma bond. Okay. So now this is the structure of ethylene molecule. So now here bond angle. Bond angle. Here bond angle is 120 degrees. Okay. So what is the shape? That is a geometry. Okay. Trigonal planar. Trigonal planar. So number of sigma bonds. Number of sigma bonds. Okay, already I said all single bonds are sigma bonds. All single bonds are sigma bonds. In a multiple bond, one should be sigma, remaining all are pi. So total now 1, 2, 3, 4, 5. How many sigma bonds? So 5 sigma bonds. How many pi bonds? So pi bonds. Number of pi bonds 1. So now this is the formation of ethylene molecule. Ethylene molecule by using sp2 hybrid orbitals.